Okay, I can't tell if I paused it or if I just started it. Either way, hello, good morning. Okay, so we're going to start today by going over the problems I asked you to do last week. So this was the last slide of last week's work where we started looking at differential equations, which, just as a reminder, are equations where you see both like a y and its derivative. So dy dx are both in a single equation, and you are asked to solve it, okay, whether it's by a general solution or a particular solution. Either way, you are finding a solution, okay? Just a heads up too. So I'm so tired today. I just don't want, I'm getting more and more tired of the stuff, but hopefully you guys are pressing through and still learning. And yeah, so if you guys can relate, I don't know, give me a little shout out on Remind or something. And okay. And then, oh yeah, so this week I'm only going to give you guys one set of notes and a couple worksheets to work on. Give me till tomorrow to post solutions for the worksheets, and check your work as always, and then ask questions if it's not matching. Or of course, if I didn't do one right, let me know with nice amounts of grace. And then if you have any questions on that, we can talk about it on Thursday's Zoom, okay? And then I'm also assigning the SEL work today. Super excited. They have Google Classroom or Google Docs now instead of a writable PDF, so that's going to be exciting for all of us. But yeah, okay, so all right, so let's get to this. My next slide, I put it blank for us. So the first two, we're going to find a general solution. Oh no, what did I do? Okay, hold up. I'm going to pause, but it's going to come back quick for you. Okay, there we go. Okay, so I put them real tiny right there so we can look at them. But let me find my little pen. Let's do blue. So I would write this first one. So number 1, dy dx. Thank you. Oh my gosh, my husband brought me coffee and it has whipped cream. I'm so excited. Thank you. Okay. So dy dx equals, then that has 3x squared over y. So we're going to follow the directions or the steps. The first step was to write it as dy dx. And so since it's already there, that one's good. Our next one is to get the x's all on one side. So the x's and dx's together on one side, and the y dy's together on the other side. Bring that down a little bit. Okay. So, so here, this side, we need to get rid of that dx. I should have wrote myself a little bit more room. So I would multiply both sides by dx. Do we have any Seattle Seahawk fans out there? Look at that beautiful Seahawk color. Okay, and so then that would cancel my dx's. And then on this side, I want to move the y. So I'm going to, right now it's being divided by y. So I would multiply both sides by y. Okay, and then that cancels the y's over there. So on the left, let me get back to blue. I now have y dy equals 3x squared dx. Okay. The next step was to integrate both sides. Okay, each side you're integrating with respect to the variable that's there. So this one is integrating y with respect to y, and on the right we're integrating x with respect to x. Now they're both indefinite integrals, but we're only going to put the plus c on one side, and I'm going to put it on the side with the x. Okay, so here on the left, when I integrate just a y, I would get y squared over 2. That was weird. I don't know what happened on that piece. just erased everything. Can I undo? Oh, I'm so sad right now. Okay, hold up. Back to this. Number 1, dy equals 3x squared over y. And then we had multiplied both sides, right? If you didn't get it, just rewind the video. Okay, pause as you need. That was the last thing I forgot to say, was pause as you need to go, or skip through this, right? You can fast forward, pause. That's the beauty of it being on a video. Okay, so we ended up with y dy equal to 3x squared dx, and then we were in the process of integrating both sides. So y squared over 2 equal to 3. Why is it doing that? Okay, we're not going to erase all sides. It's so weird. I think it's something to do with my 3x cubed over 3. So those would cancel, right? And then we'll have a plus c on this side. Okay, and then so for a general solution, we need to get y by itself. So we would multiply both sides by 2. So this whole side gets multiplied by 2. Cancels there, leaving us with y squared equals 2x cubed plus 2c. And then to get rid of the square root both sides. So y, we're going to leave it that time, equals square root, oh no, we're deleting it. What the heck? I wonder if it's something to do with the mouse and the mouse pad or something. I don't know. Ooh, don't ever press all, erase all ink. It's horrible. Y equals square root of 2x cubed plus 2c. Okay, you can write just c because 2 times a constant is still a constant, but it's still fair to remember that your c was really like a 2 times what it used to be. Okay, so that's kind of up to you. I like to just leave it with the 2. It makes it easier for my life. Okay, so that would be your general solution, because y is by itself and there's still a c in the problem. All right, so number 2 is again already written within dy dx, so that's nice. And then this side, the right side, this time the right side doesn't have any y's, so that's cool. Okay, so here we're going to multiply both sides by dx. Okay, so then those dx's cancel, and I'm left with dy equals x minus 2 over x dx. Okay, this line came because my computer's being weird, so this line not there. All right. So since we're going to integrate both sides, and I really don't want to deal with like a quotient right here, I'm going to divide each of them. So I'm going to take the denominator and give it to each of them. So x divided by x is 1, and then minus 2 over x. And that's going to be with respect to x. And then dy is on that side. Okay, so now I'm going to integrate that side and integrate that whole side. On the left, when I integrate with respect to y, it's like there's a 1 right here. Okay, and so if I had a 1 with respect to y, integrate that would be y equals, and then on the right-hand side over here, thank you, I have the antiderivative of 1 with respect to x is an x. Okay, so that's why it's super important to pay attention to the with respect to. The dy means you're doing with respect to y's, and dx means it's with respect to x's. Okay, and then here, whenever you have the x on the bottom, if we were to, we just need to remember that the antiderivative when the x is on the bottom is ln. So I have minus 2 times ln absolute value of x plus c, because we're going to do the plus c on the right side with the x. And then this is actually it, guys, because y is already by itself. The directions are to get a general solution. So y is already by itself, and I have a c in it. So that is actually my, that's my general solution. Okay. All right. So next slide. Find the particular solution. I did not have you do the last one. So we're going to do the same thing. This time we have y prime. So we're going to write it out as dy dx equals 2y over 3x. So we're going to get the y's by themselves and the x's by themselves. So in this case, the y is on the top. So I would need to divide by y to get those y's to cancel. And then to bring the dx over, I would multiply both sides by dx. So dx is canceled. So on this side, I'm left with 1 over y, right? Because it's on the bottom. dy equal to 2 over 3x dx. Oh, that's so annoying. Okay, and then this you can look at also as 2/3 times 1 over x. That might help you with our, when we integrate right now. That line is so annoying. I don't understand why it's happening. If you guys have any ideas, let me know. Okay, so next up we need to integrate both sides. And so the antiderivative of 1 over y would be ln of y. Hold on, I'm going to ask my husband, so I'm going to pop. Okay, equals 2/3 is a constant, so that comes down. Ln of x. Oops, no dx. Let me erase that. Okay, plus c. And then we're going to use the trick that we used last week. So first thing I'm going to do is I'm going to take this 2/3, and one of my logarithm rules is that when it's multiplied here, it's the exponent of what's inside the logarithm. So ln of y equals ln of x to the 2/3 plus c. I can take and I can e both sides, and that cancels that e. And on this side, it actually cancels that first ln. So, so up here we have y equals, and then we have e to the ln x to the 2/3 plus c. And then remember, the trick was that you can take and it's saying e to the c, because if we combine that same base, it would add the exponents. And so on this one on the left, the e and the ln cancel. And then on this one on the right, we just said e to any constant is still just going to be a constant. So this becomes a giant C. Okay, so y equals C times x to the 2/3. So this is a general solution, and then we want a particular solution. So we have to go back and use the information that was given to us in the beginning, where x was 8 and y was 2. So y was 2 equals C times 8 to the 2/3. Okay, and so cube root of 8 is 2. 2 squared is 4. So 2 equals 4 times C. Divide both sides by 4. And so C equals 1/2. So then for my particular solution, I go and I plug that back in. Y equals 1/2 x to the 2/3. Done. Okay. Okay, hold on, guys. There we go. Okay, so like I was saying, that is the particular solution because I found what C was and plugged it in. Okay. Okay. So today we're gonna do some more on differential equations and follow the steps to solve a differential equation. Infectious disease spreads through a large population according to the model y equals % of people exposed to the disease. T is the time in years. So it's already written as dy dt equals 1 minus y over 4. Okay, so you can solve the differential equation given that y sub 0 equals 0. So you can get your particular solution. Okay, so pause and try it. And then number 2 down here is dy dt equals ky. So that looks interesting, right? Because I have this k and I have y's and t's. So this time we have 3 variables. But you actually just take that k and treat it as a just a constant. And so when it's being taken the antiderivative with respect to x, it would just be like kx. So just like if you had the antiderivative of 5 with respect to x, it would be 5x. So if you have the antiderivative of k with respect to x, it's kx. Okay. So pause, do it. Okay. All right, so here's the solution to the second problem with the k in it. All right, so we started with dy dt equals ky. We would need to get our t's on one side and our y's on the other. So multiply both sides by dt to get this. And then I need to get rid of this y, so I would divide both sides by y, so it would cancel on the right, and then on the left I would have 1 over y. dy equals k dt. I would integrate both sides. All right, so antiderivative of 1 over y with respect to y, and then antiderivative of k with respect to t. So ln of y equals kt plus some constant. Okay, so it was a constant with respect to t, so that's why it became kt. And then to get y by itself, I would e both sides. And then the trick is that this second part can become e to the c sub 1, and then that itself becomes a constant. Okay, so y equals c e to the kt. Now, does this look familiar? Okay, so hopefully this problem or this solution looks familiar to you. I will explain exactly what it is in just a few slides, okay? All right, so differential equation still. Our question here, our EQ, is what does it mean to be directly or inversely proportional to something? And so there's all these little formulas or something like that that you need to learn, okay? So proportionality and variation. So if you see V is directly proportional to T, sorry, let's look here first. K is some constant. Okay, so K is a constant. We use K. V is directly proportional to T translates into V equals K times T. Okay, if V is inversely proportional to T, that translates to V equals K divided by T. Okay, so these are important, and it's important that this is the equation that goes with this wording, and this is the equation that goes with this wording. All right, another wording that you will see are T and P very directly. Okay, so very directly means T equals K times P. T and P very directly, T equals that, adding that constant K times P. If something varies jointly with T and P, think jointly together, right? So V equals K times T times P. So they get the varies directly and then varies jointly, all multiplication right in there. Okay, so writing an equation, how do we translate English into our math sentences? So I'm going to go through these. I want you to try it. You can pause it as you go, or I'll go slow enough that hopefully you have enough time. But if not, just pause, write it, and then check your answer. Okay, so number 1, Q is proportional to the square root of Z. Okay, so Q is proportional. That's going to be multiplication on the right-hand side. And it's Q equals, Q is K times, and then the square root of Z. So Q equals K times the square root of Z. R of T is increasing at a rate inversely proportional to itself. So this one is a little tricky. Because it has this whole rate thing going on. And so a rate actually is represented by the derivative. Okay, so the derivative is the slope of the tangent line. And so when we have R of T is increasing at a rate inversely proportional to itself, that rate one gets to be R prime of T and then equals K over R of T, since it's that inverse. Okay, this one, what do you think? W is changing at a rate jointly proportional to X and Y. So W is changing at a rate. So when we see rate, we need to use the derivative. Good. So W is changing at a rate, so W prime, and then jointly proportional to X and Y. So that's how you get the K times X times Y. And then Z varies directly with the square of X, not square root, the square of X. So Z equals K times X squared. Okay, so those are taking those words and writing equations from them, or for them. Okay, so check this out. That Y equals CE to the KT. That is your growth and decay model for exponential growth and decay, which you guys have done prior to this class. And I believe we actually did some of this in the beginning of the year also. So you've done it before my class and after, and during. So connecting it all, okay, so if you remember or you look back, the warm-up was, number 2 was dy over dt equals k times y. So the rate of change of y, right, it's a derivative, is proportional to the value of y. That's how we get the k times y. Then when we take that and get a general solution, y equals ce to the kt is the general solution to my differential equation dy over dt equals k times y. And then here's your reminder of what each of the variables stand for. Okay, so y is the final amount after time has passed. C is the initial amount. K is the growth or decay rate. And then T is the time in years. And then remember, E is just E. Okay, so some examples of exponential growth and decay: bacteria, cells in a culture, radioactive isotopes, the law of cooling, sound amplification, compound interest, atmospheric pressure, strength of earthquakes, and animal populations. But that would have to be barring any limiting factors. So meaning like if there was a predator or the weather or whatever. So if animals were able to populate with no limit, they would have exponential growth. Okay, let's look at this. So our example for radioactive decay, we have a half-life of carbon-14 is 5,715 years. How long will it take 10 grams of carbon-14 to decay to 1 gram? So we would start off with our problem. This has 2 pieces, right? Because we're going to be missing some stuff. So we need to find our rate of decay. And so half-life, I chose that the initial amount was 2, and so then half of that would be 1. You could have chosen an initial amount of 100, and then what would be left? 50. Okay, the important thing is it's going to be, oh, I almost covered this with my hand. When you divide these two, right? So if I got E by itself divided by 2, I would get 0.5 because it's the half-life, okay? So I could have just started with 0.5 and then not had the numbers at all. Okay, then we need to get rid of E. So we ln both sides. And then that would, let me see what that's the same thing. And so then ln and E would cancel each other out. Ln and E would cancel each other out. And so we'd be left with ln of 0.5 equals 5715K. And then I would need to divide both sides by that. Okay, so K is by itself equals ln of 0.5 divided by 5715. And that is approximately negative 0.000121. So this is my K value. Okay, and so I'm going to use that over here. How long will it take 10 grams? So 10 grams of carbon-14 to decay to 1 gram. So this is your Y. This is your initial amount. And then how long? I'm looking for T. All right. And then we found K, right? So we plug it in. 1 equals 10 times e to the negative 0.000121 t. I would divide both sides by 10. And that's how you get 0.1. Divide by 10. Divide by 10. 0.1 equals e to the negative 0.121 t. Get rid of e. So ln both sides. So that cancels. And then I need to get t by itself. So I divide both sides by this whole long thing. I don't want to write it with my mouse. So notice I didn't do ln of 0.1 first, right? I want it to be the most accurate that it can be. So I don't want to round until the end. All right. So I don't do ln of 0.1 first. I just wait till the end. So when I take ln of 0.1 divided by negative 0.000121, I get approximately 19,030 years. So for it to go from 10 grams of the carbon-14 to 1 gram, it would take over 19,000 years. Crazy, huh? Okay. So that's it for us today. You guys are your assignment for this week. I'm only going to post 1 set of notes, and then I'm going to give you guys 2 worksheets that I want you to do. I don't know what this is. So I'm going to give you 2 worksheets. The second one, I'm going to grade it. So please make sure you post your work and everything. Because I want to see how you are doing. Okay, so really, 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 please do not think of this as like a moment to cheat. That really doesn't do anything for us. We want to make sure, do you understand the material? Cheating literally does not benefit you at all. Trust me, okay? So I would like to see how you are doing and how you are learning. Obviously, you can use your notes. You can use these videos while you're doing it, but I want to see, can you do the problems kind of on your own with obviously the supportive notes. Okay, that's it. That's all I have for you guys. Hopefully you have a wonderful week, and I miss you, and so make sure you come see me on the Zooms. Okay, all right, bye guys.